Okay, now here's another example of curve sketching. Now the last example was a polynomial, probably would have been a little bit easier because polynomials are typically nice. Now here we got a really weird function. We've got the 1 over x plus ln of x, okay? We're going to sketch the curve of this thing. Now, first off, let's find the domain. Domain of 1 over x. This is a rational function. So the domain of a rational function is all real numbers except for the derivative equals 0. Well, the only place, where the denominator is equal to 0, not the derivative, where the denominator is equal to 0. The only place that the denominator is equal to 0 is when x is equal to 0. So the domain is from negative infinity to 0, union 0 to positive infinity. Now let's look at the domain of ln of x. It's a log function. The domain of log functions are from 0 to positive infinity. Okay? So if I got the domain of this and I've got the domain of this, what is the domain of this? The domain of this function here is the stricter domain of the two here. Now, if I were to choose this as my domain of my original function, let's see why it can't be the domain. You see this part and this part are the same, that's fine. But this part right here, this is from negative infinity to 0. If I were to plug negative numbers in here, I'd be fine with that. Negative 5 would be negative 1/5. But if I were to plug negative 5 into that, we know that we cannot take the logs of negative numbers. Now, I'm going to be careful saying that because mathematically it is possible to take the log of negative numbers. However, that gives us imaginary numbers, and we're not dealing with imaginary numbers. We're only dealing with real numbers. So we can only plug in positive numbers into here. So that means we can't use this part of the domain for our function. So our domain is going to be the stricter domain of the two. It's from 0 to infinity. The next step is to find the intercepts. So let's go ahead and find the x and y intercepts. Let's talk about the y-intercepts first. To find the y-intercepts, you plug in x equals 0 and then solve for y. But we have a problem plugging 0 into this function because 0 is not in our domain. There is not a bracket here, so that means we are not including 0. So it means we can't plug 0 into here, therefore there are no y-intercepts. No y-intercepts. So let's put a line. Separate the two. Now let's talk about the x-intercepts. X-intercepts, you plug in y is equal to 0 and you solve for x. If possible. Okay, let's go ahead and set this function equal to 0 because that's what that's saying. You just set the function. Equal to 0. Now we just got to solve. I'm going to multiply both sides of this equation by x. 0 times x is 0. X times 1 over x is 1 plus, distributing it here and here, x ln of x. Alright, so let me minus 1 on both sides. Minus 1. We get x ln of x is equal to negative 1. Alright, so we don't have any good algebraic way to solve this. So what we're going to do is we're going to use our calculator to help us solve this. So what I'm going to do is I'm going to plug in to y1 x ln of x. And in y2, I'm going to plug in negative 1. And then I'm going to look at the graphs. Now, I do change my window a little bit. Let me tell you what I have my window as. So in the x direction, I'm going from 0 to 2. And in the y direction, I'm going from -3 to 3. That's just so I can get a good, clear visual of the graph. And see, my calculator is drawing it right now. And then if you were to look at this graph with this into y1, this into y2, and you have these windows, here is the graph, okay? As you can see, the curved line that goes up, that's my x ln of x graph. This horizontal line down here is the y is equal to -1 graph. The one going through the middle is just the x-axis, okay? As you can see, there is no intersection point. Therefore, this graph never has an x-intercept, because if it did, we would be able to solve this equation right here for an x value such that when we plug it in, it equals -1, okay? We cannot do that, so this also has no x-intercept. No x or no y or x-intercept. Okay, now let's just say it did. Let's say they did cross for somewhere. What you would do, you'd hit your second key, and then you'd hit your trace button, and you'd go to number 5, which is intersect. And it asks you first curve, second curve, then you got to guess, okay? Not always will functions have x and y intercepts. That's okay. The next one, check for symmetry. So, let's see, if I plug in -x, that's equal to 1 over -x plus ln of -x, we run into a problem right there. Ln of a negative number. Our x's here are always positive because of our domain. So if I always have to plug a positive number in here and then the negative sign makes it negative, this ln will be undefined. I can't find ln of negative numbers, okay? So I cannot clearly define f of -x, therefore I can't check for symmetry, meaning there is no symmetry here, okay? So no symmetry. All right, let's see. Find the asymptotes. This is a good one. Now, we can easily see asymptotes. Let's talk about the vertical asymptotes. Since this is a rational function, the vertical asymptotes are also where the denominator equals 0. So we've got a vertical asymptote at x equals 0 because I cannot plug 0 into here. We also have vertical asymptotes stemming from the ln function. There is an asymptote also at x equals 0 because ln of 0 is -infinity. If you recall the graph of a log function, it looks something like that. So as I get closer to 0, it goes down to -infinity. Therefore, this right here is a vertical asymptote. You could also define this as a limit. If you recall, the definition of a vertical asymptote is the limit as x goes to some value a, in this case 0, of our function. If it equals plus or minus infinity, this number here is a vertical asymptote. In fact, it's going to equal one of them. We'll see later on. But as we get closer to 0, we do run into a problem. We have a vertical asymptote. Now for the horizontal asymptotes, we could take the limit as x goes to infinity of our function, and if this equals a finite number, then we have found a horizontal asymptote. So we've got a vertical asymptote at 0. Let's see if we have a horizontal asymptote. So if I just plug in infinity, 1 over infinity plus ln of infinity, Well, 1 over infinity is 0 plus ln of infinity is infinity. So it did not go to a finite number. Therefore, there are no horizontal asymptotes. So let's record that over here. Asymptotes only at x equals 0. Now we could have checked the other direction. The limit as x goes to negative infinity. However, if you look at our domain, it's from 0 to infinity, so we didn't need to check that other one, okay? Finding intervals of increase and decreasing, okay? So we need to take the derivative. F prime of x is equal to the derivative of 1 over x. If you rewrite it with a negative exponent and then apply the power rule, is negative 1 over x squared, plus the derivative of ln of x is 1 over x ln of e, but the ln of e is 1. So here is our derivative. Now, in order to find the intervals of increasing, decreasing, we need to find the critical numbers so that we can put them on a number line. To find critical numbers, you take the derivative, you set it equal to 0, and solve. So I'm going to take my derivative, negative 1 over x squared plus x, 1 over x is equal to 0. Let me rewrite this. Now, since I have x's on bottom, I'm going to multiply both sides of the equation by x squared. I'm multiplying both sides of the equation by the least common denominator of this thing. The reason being is because when I multiply it over here, it's just going to be 0. And when I multiply it over here, it's going to knock out these denominators. Okay? So as I already said, on this right side we get 0. If I distribute here, x squared divided by x squared, that's 1. And then we got a negative in front of it, negative 1, plus, if I distribute over here, I got x squared divided by x, which is just x. Hey, look at that. Really easy equation to solve. Plus 1, plus 1,